Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.73. While solving this problem, we will be using current divider rule. Basic equations for the calculation of current I1 and I2 of this particular circuit using current divider rule is provided here. We also will be using Ohm's law. According to Ohm's law, voltage across any resistance R is always equal to the product of current through that resistance and the value of resistance. Now move towards the problem. Exercise problem number 2.73. Find voltage V0 in given below figure. This is the circuit diagram of given problem. In this network, we have to calculate voltage across this 1 kilo ohm resistance labeled as V0. So without wasting time, let's proceed towards the solution. There are two total number of nodes inside this network. One is this and other one is this. On this node, one current of 18 milliampere is entering and other current of 30 milliampere is leaving from this node. So first of all, we will calculate their equivalent current by subtracting 18 milliampere from 30 milliampere because of opposite direction to each other. The resultant current will be 12 milliampere and it will be leaving from this node because the higher value of current was leaving from this node. Now the circuit is simplified. There is a constant current source that is connected parallel to two resistive networks. So we can calculate the current through this branch using current divider rule, and we are interested to calculate the current of this branch so that we can calculate voltage across this 1 kilo ohm resistance using Ohm's law. Before applying current divider rule, we have to label these branch currents. This branch current will be labeled as I1 and this branch current will be labeled as I2, and we are interested to calculate the value of current I2. For that purpose, we will use this current divider rule equation. I2 is equal to R1 divided by R1 plus R2 multiplied by I into T. In this equation, IT is total supplied current. In our case, it is 12 milliampere. R1 is the resistance of opposite branch. In this case, it is 3 kilo ohm. And R2 is the resistance of same branch. In our case, it is the sum of 1 kilo ohm and 5 kilo ohm. So R2 will be 6 kilo ohm. Place values inside this equation. I2 is equal to 3K divided by 6K plus 3K multiplied by 12 milliampere. Take the product of 3K and 12 milliampere. It will become 36 only. K will cancel out with milli. And the sum of 6K and 3K will become 9K. Now divide 36 with 9K. The value of I2 will be 4 milliampere. 4 milliampere current is flowing through this branch and the direction of current is upward. This 12 milliampere current is entering on this node and it is leaving from these two branches. So the direction of current through this branch will be upward. Now using Ohm's law, we will calculate voltage V0. Equation of voltage V0 will be equal to I2 multiplied by R. I2 is minus 4 milliampere and R is 1 kilo ohm. Here we have taken current with minus sign because current is entering from negative terminal and leaving from positive terminal. Take the product of minus 4 milliampere and 1 kilo ohm. Milli will cancel out with K and the product of minus 4 and 1 will become minus 4 volt. So the value of V0 inside this network is minus 4 volt. So this was exercise problem number 2.73. Thank you. See you again in next video.